Recall that the evaluation theorem says that if big F prime is little f, then the integral from a to b of little f of x dx is f of b minus f of a. So let's think about a case here where we're interested in the level of a chemical, big F of t. The rate of change of the chemical would be f prime of t is little f of t. And so we think about the integral from a to b of little f of t dt would be equal to the integral from a to b, big F prime of t dt, and that's going to be equal to f of b minus f of a. And so this is the net change in the chemical here, the amount that we finish with minus the amount that we start with. If we have a population, say n of t, we're interested in the rate of change of the population, dn dt. And so if we think about the integral from a to b, dn dt, this is going to be equal to n at b minus n at a. And so it's a population at time b minus the population at time a. And so this is the net change in the population between time a and time b. If we're a physicist, we might be interested in the rate of change of position of an object. And so that would be s prime of t, which would be the velocity of the object. And so if we take the integral from a to b of v of t dt, this is the integral from a to b s prime of t dt, and this is going to be s of b minus s of a. And that will be the net change in position of the object between time equals a and time equals b. Let's apply this idea of net change to the rate of growth of a fish. So we suppose a fish starts life at 1 centimeter and has an age-dependent growth rate given here as big L prime of a is L of a is 29 e to the minus a. Here a is the age in years. And we ask ourselves, what is the fish's length after 5 years? And so we can write this in terms of the net change idea. And so we write L at 5 minus L at 0 is equal to the integral from 0 to 5 L prime of a dA, which is the integral from 0 to 5 little L of a dA. And this is going to be equal to integral from 0 to 5, 29 e to the minus a dA. And we can pull out the 29, so we have that's 29 times the integral from 0 to 5 e to the minus a dA. And so we have that this is equal to 29, and the antiderivative of e to the minus a is minus e to the minus a, and we evaluate that between 0 and 5. And so this will be equal to 29 times minus e to the minus 5 minus e to the 0. And notice that e to the 0 is 1, and so we have minus minus 1. So this is plus 1 right there. And so this is equal to 29 into 1 minus e to the minus 5. And when we put that on the calculator, that's equal to 28.8. And so notice we started off with L5 minus L0, and L at 0 is equal to 1 centimeter. And so we have L at 5 is equal to L at 0 plus 28.8. And remember, this is equal to 1. So this is equal to 29.8. And so at the end of the 5 years, the fish's length, should be 29.8 centimeters. And so by looking at this from the process of net change in the evaluation theorem, we can solve this problem to do with the fish's length after 5 years.